Hello everyone. Can you please comment in the comment section so that I can understand whether my audio and video is clear or not? Please place and comment in the comment section so that I can understand whether my audio, I am audible or not, and we can start the live. Okay, so it seems good. So hello everyone. Thank you for joining in. So today in this session we will be learning about the previous year questions. Mainly we will be solving the previous year questions on the lexical analysis, and this is a specific topic of compiler design. Okay, so just starting with the very basic thing. First of all, I hope that you have the idea with the lexical analysis. So what is lexical analysis? This is the first phase of our compiler design, and in this phase we just take the character string, or you can say the source code, and we convert the source code into our tokens. Okay, string of tokens. So in this session, basically, we have earlier talked about, in the other live sessions, we have already covered the basic concept on this lexical analysis, and today we will be solving the previous year questions. Okay, so starting with the first basic question, this question was arrived in the GATE 2018. Okay, so you will find in the GATE 2018 computer science paper, this question was there. So how to solve the question? First of all, okay, let it be. Can you wait? Try to solve this question and put the answer in the comment section. Can you push your own intuition and solve the question first? I'll then wait. Okay. And okay. Hi Dhruv, it's difficult to talk in Hindi or Gujarati because like people from different parts of India is watching the special live session. So if I take some local language, it will be difficult for everyone to understand. So please stay with the English. Okay. So anyway, this question I'm trying to solve. Let's see. First of all, you can understand that it is saying a lexical analyzer uses the following pattern to recognize three tokens. There are three tokens. One is T1, T2, and T3 over the alphabet ABC. So this is the set of alphabet, and we have three tokens. So what are those tokens? The tokens are this. Okay, these are the token. But what does it mean? It means that this X question mark, it means 0 or 1 occurrences of the symbol X. Okay, 0 or 1 occurrences of the symbol X, and the analyzer outputs the token that matches the longest possible prefix. Okay, longest possible prefix. Find the word. And the string is BAA, BBAA CABC. Okay, is the process by the analyzer which one of the following is the sequence of the tokens it outputs. Okay, there are four options and one option will be the correct one. So firstly we should understand that what does this tokens means. Okay, what is what it is saying. First of all, if you see this a question mark means what? It is showing either 0 or one occurrence of the symbol X. Okay, it means that T1 should be either 0 occurrence of A. So if there is 0 occurrence of A, it means that no A should be there. Okay, if in this token no A is there, so it will be only B or C star and A. Okay, and there may be one occurrence of A. So if there is one occurrence, so we can say that an earlier one, okay, earlier A should be there, and after that B or C star and then A. Okay, so in this two way the T1 token can form. I hope that you are understanding that. See, the prefix A, okay, the prefix A, there might be the prefix A or not, because it says that there should be 0 or 1 occurrence of the symbol X. Okay, and here In our case, the symbol is A. Okay. So this is the token T1, and in the same way, the token T2 will be our A or C star B plus B will be, I mean, here the number of occurrences of B is 0. Okay. The prefix B is 0, and here the number of occurrences of the prefix B is 1. Okay. Because we need to consider both of these options. So it is A or A star and B. And after that, T3. So T3 is what? T3 is in the same way. It is B plus A, I mean B or A star C, and C in the prefix, then B or A star and again C. Okay. So there will be, I mean, these three types of tokens are there. Okay. Now what is our string? Our string is what? Our string is B B A A C A B C. Okay. This is the our given string. The string is given here. So we need to match these four options. Okay, and we need to understand that which option is the perfect answer for generating this string. Okay, or you can say for parsing this string. So firstly, we can analyze one by one options. Okay, firstly, if we talk about the option A, okay, if we talk about the option A, so we can see that it is having T1, T2 and T3. So T1 and, I mean, T1, the token T1 is ending with what? Ending with the element A, right? And token T2, it is ending with the element B, as well as token T3, it is ending with the element C. Okay, so these three tokens are there, right? I hope that till this part it is more clear. Okay, so let me see if there are any questions are coming. Okay, so that's fine. Let's stay here. Okay, so this option A, okay, what is the, I mean, if we use the option A, will it be, I mean, will it be possible to generate this string? Let me think. Okay, so first of all, ending with A. So in the T1, T2, T3. In T1 we can use, I mean, this one. If we generate up to this, okay, B B A, okay, this part can be generated from T1. Okay, after this, the double A is not possible from T1. Okay, it is not possible. Then the next token is coming, that is T2. Okay, so from T2 how much we can generate? So we can see that from T2 it is possible to generate ACA ending with B. Okay, so I think in T2 it is possible ACA, I mean from this side, okay, this part we can generate ACA and then ending with B, and lastly from T3 we can generate C. Okay, from T3 we can generate C. So in this way, using the token T1, T2, T3 we can generate the whole string, but the problem where comes that it matches the longest possible prefix. Okay, so our token should be minimal. Okay, and it should match the longest possible prefix, but here in this case it is not the longest possible prefix. Okay, all of them we won't think that it is the longest possible. Okay, so let's generate the option D. Okay, try to explore the option D. So what it is saying, T3 and T3, fine. So first T3 says what? So if we see the string again, B B A A C A B C. Okay, so we can see that our ending of this token 3 T3, okay, is with the symbol C, right? So here we can divide accordingly. So we can divide our whole string in these two parts. Okay, in these two parts we can divide the whole string, and we can see that yes, both of them are ending with C. Okay, and the other part can be generated from B or A star. B or A star means we can use multiple B's and multiple A's simultaneously. Okay, so first part and the second part can be generated from T3 only. Okay, and it is using the longest possible prefix. You can see that the number of tokens are minimal also here. Okay, so the correct option comes, that is the option D, right? So I hope that you are getting the main points, that here we need to follow the lowest number of tokens, right? So here the lowest number of token is this one. I mean, here in the option D, it is saying that two T3s. Okay, it means that two tokens we are using. And here by using T3 only, we can generate or we can parse out the given string. Okay, so the correct option, the appropriate option here in this question will be option D, right? So I hope that you are getting the points, right? If you have any questions, please feel free to ask. Okay, we are checking your comments so that we can give you the proper answer. I hope that it's okay till now. Fine. Moving forward to the next question. So it is saying what? See, this lexical analysis questions, these are the very basic question of compiler design. Okay, this is the first part of compiler design, as I already told, and the questions comes from this lexical analysis, or maybe you can encounter 2 to hardly 3 marks question from this lexical analysis part, and the questions will be like medium to easy. Okay, there won't be any hard questions from this lexical analysis. Mostly the questions are very easy. Okay, and you need to understand the compiler design basic things to solve this lexical analysis questions. Okay, like this question you can see. So this is not basically a question from lexical analysis. It is I mean you need to have the whole concept of compiler design to answer this question. So it is saying what? First of all, it is the GATE 2017 question of Set 2. Okay, and it is saying that match the following according to the input. Okay, so in the left side, in the left column, there will be the inputs and to the compiler phase, and in the okay, yeah, these are the inputs, and the right column it is saying that these are the compilation phases. Okay, so it should be like syntax tree, and what should be the input in the syntax tree. Okay, the matching will be similar to like this. So first of all, we need to understand that how a compiler works. Okay, how a compiler works. So this was already talked in our like normal live classes, so I'm just repeating again. First of all, see, you place your source code. Okay, what a compiler basically does, first of all, you place your source code. Maybe it should be in C, C++, Java, any language. Okay, you are placing your source code that can be named in the given option, that can be named as character stream. Okay, so this is a character stream. Fine. So source code. So source code, what is the first phase of our lexical, and I mean first phase of our compiler design? That is what? The lexical analysis, right? So lexical analyzer. Okay, so we are putting the source code or character string in the lexical analyzer. Okay, so what this lexical analyzer is doing? Lexical analyzer is taking the source code and it is generating the string of tokens. Okay, I mean all the operator or all the operands will be converted to some specific predefined tokens. Okay, so the lexical analyzer will generate the token string. Fine. So after this lexical analysis phase, what is the next phase? The next phase is what? It is simple, right? It is the syntax analyzer. Syntax analyzer is the next phase after this lexical analyzer. So in syntax analyzer, what happens? In syntax analyzer, we generate the syntax tree. Simple. In syntax analyzer, we generate the syntax tree. Okay. So after generating the syntax tree, what is the next phase? That is obviously the semantic analyzer. Okay, semantic analyzer, right? And from the semantic analyzer, what we get from the semantic analyzer, basically we get our semantically verified parse tree. Okay, from the semantic analyzer, basically we get the semantically verified parse tree, or you can say the syntax tree. But ultimately, with the semantic analyzer and our intermediate code generator, okay, after both of them, we get the result of intermediate code. Okay, so what is the phases? So these are the phases of compiler, right? First of all, the source code. Okay, source code means our code in C or C++ or Java or in any language. So those are, we can say, the character stream, and those are put to lexical analyzer, and lexical analyzer is outputting the token streams. Fine. So the set of tokens, or you can say the string of tokens, will be the input of syntax analyzer. And what is the output of syntax analyzer? That is the syntax tree. Fine. And syntax tree will be then will go to the semantic analyzer part. Fine. And from the semantic analyzer, what is the output? That is the intermediate code. And from intermediate code, it goes to code generator. Okay, code generator means what? Code generator is actually generating the machine level code, or you can say the assembly code. Okay, because ultimately our target is to convert our source code or the high level languages to the machine level language, right? So from this code generator, so code generator is doing what? It is taking the intermediate code, okay, and it is converting to the machine code. Okay, machine code. This code will be understandable by our machines. Okay, maybe it's our like Windows, maybe it's an iOS device or whatever. Okay, code generator will finally generate the machine code. Now coming to the question, it is saying that syntax tree. Okay, we should need to understand, we should need to match the inputs. Okay, so syntax tree, what is the input for the syntax tree? We can see the input for the syntax tree is token stream. Okay, so sorry, let's talk about, these are the phases, right? So code generator. Okay, so what is the input for the code generator? That is, we can see the intermediate representation. Okay, so for r, what is the part? That is 1. Okay, so the option 3 is actually matching, right? Let's check again. For r, this is the code generator. Okay, let's start with the P. Okay, syntax tree. Syntax tree will be the input of our semantic analyzer. Okay, so P goes to 3. This is the correct. And then character stream. Character stream will be the input of our lexical analyzer. Fine. So Q tends to 4. This is also correct. Then intermediate representer. This intermediate representation, it is the input for our code generator. Okay, so it means what? R goes to 1, that is also correct. And token stream, that is the input for our syntax analyzer, right? Token stream is the input for our syntax analyzer. So overall we can see that the option C is matching actually all the points. Okay, this option C is matching all the points, and hence the correct option is option C, right? So again, moving to the next question. So this question were arrived in GATE 2017 set 2. If you have any question, please put it in the comment section so that we can explain more. Okay, so basically now moving to the next question. So it is what? It is again a matching. Okay, so again a matching. It says that match the following using lexical analysis, and what is basically the job of this lexical analyzer in this way. Okay, so first of all, let's see what we know. See, lexical analysis. So, is that the leftmost derivation is the correct option? It should not be, because the leftmost derivation or rightmost derivation, these are not associated with the first phase of compiler design. Okay, lexical analysis is the first phase, but the leftmost derivation or rightmost derivation, these we have talked about in the parser. Okay, so this should not be associated with lexical analysis. So what is the next option? It is type checking. Okay, let it be. What is the third option? It says that the regular expression. Okay, so regular expression, it should not be associated with lexical analysis, because in the first phase we don't talk about the regular expression and not also the activation records. Okay, so what is left? That is the type checking. In lexical analysis, yes, we do the type checking. We understand that which are the operands, which are the operator. Okay, and depending on that, we generate the what? We generate the string of tokens, right? So P, correct option for P is 2. Fine. And I can see, let's see, no, type checking. Let me think if we have mistook anything. Okay, let me check it again. So, okay, okay, fine, fine. So, not just starting with P. First, understand that what is the top-down parsing. I mean, we'll talk about one by one. Okay. So this PQRS, right? So what does this top-down parsing is doing? What? So top-down parsing is associated with leftmost derivation, right? Because we know that in parsing, basically we need to have the leftmost derivation tree. Okay, so this top-down parsing is associated with leftmost derivation. So the Q should be 1. Okay, then in the semantic analysis, here we check the type checking. Yeah, so that I was missing basically. So in the semantic analysis, we do the type checking. Okay, we can understand that whether it is an integer or float or boolean or whatever. Okay, so R is basically associated with 2. Okay, so that I was missing basically. So anyway, we can check in the runtime environment. We always need the, this option is available, that is the activation record. This is basically nothing but the stack, okay, which records all the activated parts. Okay, so in this activation record is associated with runtime environment, and what is left? The left is obviously the regular expression. Okay, and this regular expression should be associated with P. Fine, this regular expression should be associated with P. So basically these are the 4 correct options. Okay, and here the corresponding answer should be P should be 3. So P3 is only in the option B. Okay, and let's check what are the other parts. Okay, so this is correct. So the option B for this question is correct. I hope that you have understood, right, that how all the parts are associated. Okay, all of these options are associated. I hope that you are getting the main things. Fine, let's go to the next question. Okay, if you have any question, please put it in the comment section so that we can understand. Okay, so what is next? So next is in the compiler, the keywords of a language are recognized using, okay, the keywords of a language. So what are the keywords? Those should be the operator, operand. Okay, these are maybe the keywords, the equal sign. Okay, and any operator you can say. So the keywords of a language are recognized during which part? In parsing, we basically get the set of keywords. Okay, because the string of tokens are itself the set of keywords, right? So parsing should not be the option, because in this phase we already have recognized the keywords. Okay, so in the code generation, it is the last step almost, so this should not be the answer. In the data flow analysis, it is also at the last step because it is associated with runtime environment. Fine, so what is left? That is the lexical analysis of the program. It's true that in the lexical analyzer what happens? If we talk about Lex analyzer, so what happens? The starting is the, it gets the source code, okay? It gets the source code, and upon getting the lexical analyzer, in the lexical analyzer, it generates the set of tokens or the string of tokens, okay? So in this way, the lexical analyzer basically works, okay? And so the, in this question was arrived in GATE 2011, and in this question, the keywords of a language are recognized during the lexical analysis of the program. Okay. So I hope that you are getting the previous year question. So basically, what happens in this compiler design phase, in this lexical analysis, we get the very small, or we almost get this type of questions, okay, that you have to just remember, or if you know the concept of basic compiler, then you can answer them, okay. There are no like rocket science is not there in the, at least in, not in the lexical analysis, okay. So this part is very clear. So basically I want to show you that what is the main motivation for us to uh, show all of you in this live session. So the main motivation is, let me show you that. Firstly, let me share my screen again, okay. So we can see that in the Geeks for Geeks, we have our Gate Computer Science channel, okay. In this channel, we perform the, we have the all subjects, okay. We have compiler live classes, algorithm live classes, programming live classes, as well as all the gate subject, whatever you can think of in the computer science gate, okay. Those are all, all are here, okay. So a student, and a needy student who cannot afford for some premium course or cannot go for some, coaching institute, they can come here, and these are all free, okay. We have our different instructors who place their live lectures in the Geeks for Geeks Gate channel. So do subscribe this channel and stay tuned. We have the live sessions every day, okay. Every day for one, at least one of the topics, we have our live session. So in this Gate Computer Science channel of Geeks for Geeks, we are basically making the whole set of GATE lectures, okay, as well as with the previous year questions also. So for me, this was like one of the, I'm taking today, that is the compiler design previous year question, right? And actually we have also discussed the basic, core concept of compiler design in the live class itself. So you can see the in the compiler live classes, we have almost the 12 videos. So in those 12 videos, the basic concept, okay, the content is given there. Fine. So do subscribe the channel and stay tuned for more like this, okay. And now I'm again going to the our part, that is the previous year question of compiler design. So perfect, okay. So in the next question, what it says, okay, so in the next question it says that which data structure in a compiler is used for managing information about variables and their attributes. So we know that all the variables and attributes are managed by what? Ours? No, symbol table, right? We have the symbol table structure in our compiler design, okay. In our compiler we have this symbol table, and we usually take the note of all of the attributes and variables and their information in the symbol table itself, okay. So the answer for this question should be symbol table, okay. Symbol table is the data structure in which we take the information of all the variables as well as their attributes. Okay, so fine. What is the next question? Okay, this question is a little bit good question, you can say. Okay, so what does it says? It says this: consider the line number 3 of the following C program and identify the compiler's response with this line while creating the object module. So what is the line number 3? We can see this is this line. Okay, line 1, line 2, and this is the line number 3. So what should be the compiler's response? So here, first of all, we need to understand that what is the problem here. Okay, the problem, if you see, the problem is here. It should be for. Okay, the keyword should be for, but instead of for, it is writing fro, right? So this is what this is. Which problem is this? This is the syntactic problem, right? The syntax is not correct. Okay, I hope that you are getting the point here. The syntax is not correct, right? So it should be for. So here the compiler will give the syntactic error. It is not an lexical error. It is not the compilation error. Okay, I mean compilation error will come. No, sorry, it is saying that no compilation error, but the error is there. We can see. Okay, and both lexical and syntactic error, that is also not true, because we can see that here the syntactic error is there. Okay, syntax is not true. So it should be syntactic error. I mean option C will be the right option. Okay, for this question. And for the last question we have taken for today's session is the most common question that you will encounter in the lexical analysis phase of compiler design. Okay, so it is saying what the number of tokens in the following C statement is this. Okay, how many number of tokens are there? So I am waiting for the question. Okay, I mean I am waiting for you, everyone, to solve the question. Okay, and then after that only I will answer. Okay, so let me wait for at least 5 minutes. Please try to solve the question and give me the correct answer. If you get any solution, please put it in the comment section so that I can understand. Okay, so comments started coming. Good, good. So waiting for a few more answers. Okay, so I'm seeing the correct answer is coming. That is the option C, right? 10. So let's see. Let's solve this. Okay, those who are struggling to answer the question, let's solve this. So first of all, what is the token? So token is printf, first braces, then in the bracket what is there, and percent I equal to percentage x, comma I, comma, and percent I, this one. Okay, So what is the tokens here? Okay, tokens means the basic keywords. So we can see that printf is the first keyword. Okay, let me change the color of the pen so that it will be a little bit easier. Okay, so printf is the first keyword. Okay, so this is the one. Then the first starting braces, this is the second keyword, 2. Then the whole thing inside the double inverted comma, whole thing inside the double inverted comma. If anything is given here na, in the double inverted comma, we should take him as a single token. Okay, so whatever is inside in the double inverted comma, that will be our token number 3. Okay, now this comma will be our token number 4. Now I will be token number 5, then this comma token number 6, and percent will be token number 7, then this I is token number 8, and the ending braces is token number 9, and our finally this one should be the token number 10. So how many tokens we are getting here? Overall there we can get 10 tokens. Okay, if you see, if you don't understand anything by watching this video, okay, so I should tell you that you please visit to our YouTube channel, that is Geeks Gate Computer Science, and there you will see the basic concept. Okay, first learn the concept, then come here. This session will be recorded in the channel itself, so then you will be understand, you will be understanding this whole concept. Okay, this is the very common question that you will encounter in the lexical analysis, and I see some of the proper answers. So Abhishek Sharma, so he placed the answer 10, so that is the correct answer. So thank you for learning actually. So okay, so that's fine. So after that, what is there? Okay, so one thing I have to tell you that, let me share my screen again, that we have in Gate, I mean Geeks for Geeks Gate, we have this test series launched. Okay, this is the test series for Gate 2022. Okay, and you know that in the gate preparation how much important it is to solve the question, whether the previous year question or some test series. Okay, in the previous year question you will understand that what are the basic types from which the gate authority actually makes the question. Okay, so previous year questions are very important to do a good performance in the gate itself, as well as you can take multiple test series. Okay, so from this year, this Geeks for Geeks is generating, or it is launching our gate CS test series. Okay, so you can sign up for now, and we have multiple tests with, you can say, the weekly assessments are there, in then in internship opportunity at Geeks for Geeks is there, assessment test is there, and quiz and theory based learning is also there. Okay, and we have all the subjective test. Okay, first round of subjective test is there, and then second round of subjective test. Okay, we have almost 25 combination of good questions in each of these tests, and the third round will be a full length test. Okay, and in full length test we have this 5 mock test, and all of these mock tests will be of 65 questions. If you see the current syllabus, or you can, if you see the current pattern of gate, so that is of 65 questions, 100 marks, and 3 hour or 180 minute. Okay, so the same pattern of gate will be also, I mean, you will face the same environment in the test series itself. Okay, so don't wait for time, just complete one by one subject from the Geeks for Geeks Gate channel itself, and then come to the test series and give one test weekly, at least one test weekly. Okay, so it will be beneficial for all the Gate CS 2022 aspirants. Fine. So I hope that it's clear. Okay, if you have any question in the test series or anywhere, please put it in the comment section so that we can understand. Okay, So let me see what are the questions coming. Okay, okay. So yeah, basically again, let me share our channel itself, our Geeks for Geeks channel itself, from where you can learn the basic concepts. Okay, so in YouTube you just go and search for the Geeks for Geeks gate and you will encounter the Geeks for Geeks gate computer science challenge. Here, I mean channel, here for all the subjects of gate computer science we have our lectures. We have lecture for compiler design, which I am taking, then algorithm, then programming data and data structure, discrete mathematics, linear algebra, DBMS, computer organization, digital logic, TOC, computer network, operating system, as well as GATE previous year programming questions also. Okay, and we have our some general discussions like what are the opportunities you can get after the GATE exam. Okay, so all of this we have in our GATE computer science uh, channel itself. Okay, so please visit us and do subscribe our channel so that you will get some good idea in the upcoming gate. Okay, and all the, I mean all the instructors are highly qualified. They are all gate aspirants. I mean once they were the gate aspirant and after that they are taking the live sessions, and that's doing good. Okay, so So thank you for joining everyone. I hope that you have learned a lot from this session. Okay, we took only 7 questions from lexical analysis because in the lexical analysis we don't encounter much questions. Okay, in the gate actually there are not much questions from the lexical analyzer, but from the parse tree, or you can say the syntax analyzer or semantic analyzer, there will be more questions from the from those parts. Okay, so I hope that you have understood, enjoyed a lot. If you have any question regarding anything of the live session, please put it in the comment section so that we can come up to you. Anyway, I hope that this is good. So thank you folks. Thanks for joining.